Hello students, now we will learn about sphere and hemisphere, that is how to find the surface area and curved surface area and what actually are these shapes, what actually are hemisphere and sphere. So now moving on to next slide, what is sphere? Is it same as a circle? Like have you seen a circle and you can draw it on the page too, right? Because it is a 2D plane, right? It is a 2D figure. It is a plane closed figure whose every point lies at a constant distance from the center, right? Because this is the center and every point of the circle lies at a constant distance from the center. And this constant distance is called its R. R is the radius. Now, if you pass a string, now this is a circle, and if you pass a string through this to the center, a string or a stick, and rotate it like you have done in the previous activity of rotating a right angle triangle to form a cone, then you'll see that a shape is formed, a solid shape is formed, a 3D shape is formed. And what does this shape resemble? It resembles a ball, right? And a ball is a sphere. So rotating our circle gives us a ball. So now, and the ball is actually a sphere. So a sphere is a three-dimensional figure, solid figure, as I have already told you that solid figures are the 3D figures that we see in our daily life, right? Because we don't see the 2D figures in the daily life unless we draw it on the paper. It is the 3D things that we come across in our life. So a sphere is a three-dimensional figure which is made up of all points in the space which are at a constant distance from the radius that from the radius that is called a point from radius from a fixed point called the center of the sphere. So now we have this sphere and this is a center and each point lies at an equal distance. It is similar to the circle, just it is 3D. So if we have the center over here, then each point is I'll come outside like this, and this is touching the outer point. Then all these surfaces, all these from the center till it touches the surface of the sphere. All the lengths will be all equal, and it is called our radius. Just like a circle in 2D, we have drawn a circle, and from center we are marking the lengths, and these lengths are equal. So now we'll find out the surface area of a sphere. We'll not derive it by using mathematics, but we'll show and we'll prove it by using an activity. Now you might have seen top, right? Or you would have played with it. So now, if it is so now you might have seen a top or at least played with it. Now, do you remember how we whirl or bound the string around the top? Like if this is our top, to play with it, to like this, and to play with it, we have to throw it in the air and it spins around. Now to throw it in the air, we use the string. We used to wind it around like this. Now we'll do the similar thing with our sphere. So let us nail our sphere down. So we'll insert a nail over here so that it becomes like a top. And now we'll take the string, put it over here and keep on winding. Wind this wound string around the sphere. As you reach the fullest point, just secure it with a pin so that it doesn't open and keep on winding till you reach the end. Like this. Now if we consider these lines as string, now it is fully bounded. And now mark the starting point and the ending point. Now unwind it and you have the markings, right? So you have the markings of how of what length string is used to bound this up. Now, you take your teacher's help or maybe some elder's help to find the radius of this sphere. To find it, just measure the distance from this point. So you can put a scale over here and measure it. Put a scale over here, put a scale over here. Now you can measure the distance. Now this distance is our radius of the sphere. Now With this radius, draw four different circles. You'll know why I have said you draw four different circles. Just draw four different circles and cut it out from a paper of radius r. R is the radius of the sphere. So now we have four different circles. Now take the string and start bounding these circles. So if this is the string, then we have bounded, bounded, bounded till it completely fills the circle. We'll cut it and then we'll move on to another circle. So we keep on winding the next circle, then next circle, then next circle. Now what we'll see at the end is all the string is being used after exactly four circles, and all the circles are completely filled. Now we can see that the string is covering this area of all the circles, and string is also the length of the string is also equal to the surface area of our of our sphere, because it is covering the whole of the surface area of our sphere, and it is also covering all of the four circles area. So now we can easily find out that the surface area of our sphere is equal to the sum of area of these four circles, right? So now we'll sum these over. We already know what the area of this circle is. It is pi r square. So we'll do pi r square plus pi r square plus pi r square plus pi r square. These all are identical, so I'll just put on pi and we have 4. Now we have just proved that the surface area of the sphere is equals to 4 pi r square. Now let us move on to a hemisphere. Now what would be a hemisphere? If we'll take a sphere itself and we'll cut it in half. We know now, but first let me ask you a question: that how many surfaces does this sphere have? It only have one surface. As you can see in the previous slide, if we look at this sphere, it only have one surface, and that is its curved surface area, right? So a sphere has one surfaces, but when now we have cut this sphere, and we have formed a hemisphere. Hemisphere. Why is it called hemisphere? It is because hemi means half, and we have cut the sphere into half. We will cut the sphere from here, then it is not a hemisphere. We have to cut it from the center, then only it is a hemisphere. So we have cut it in half, and now let us analyze our hemisphere. We'll see that it has two number of surfaces, and how? It is because first is this outer curve surface area, which is equal to half of surface area uh, of our cube, and then we have this circle inside, right? It has the same radius as this sphere, which is r. So circle's area is pi r square. Now if we move on to find the curved surface area, then it is equals to, curved surface area is half of the surface area of circle. Now which is half into 4 pi r square, and which is equals to 2 pi r square. Now similarly, we find out the total surface area, because it has two surfaces. Now to find them out, we'll just add the curved surface area with this second surface, which is our circle. So we'll add pi r square, and we have 2 pi r square plus pi r square, which is equals to 3 pi r square. This is our total surface area of the hemisphere, where r is the radius of the sphere, of which hemisphere is the part, right? So as we have cut the hemisphere from the sphere itself, so this r is actually the radius of the complete sphere. Now let us do examples so that you can get a better understanding at the formulas. Here we are asked to find the surface area of a sphere of radius 7 centimeter. So our radius is given as 7 centimeter. The surface area of a sphere, as we have found out, is 4 pi r square. Now let us substitute the values 4 into 22 by 7 into 7 into 7. Now we'll cut it out, and after multiplying it, we'll get the answer as 616 centimeters square. So now this is how we are finding out the surface area of the sphere. Now let us move on to our next example, example number 8. Now here we are asked to find the curved surface area and the total surface area of a hemisphere of radius 21 centimeter. So now our radius is 21 centimeter. We have to find CSA and total surface area. Now, for curved surface area, we know the formula is 2 pi r square. It is half of the sphere's area. So we have got 2 pi r square. So let us substitute 2 into 22 by 7 into 21 into 21. Now when we do that, we have 3, we cut 3. And when we multiply 2 into 22 into 3 into 21, we'll get that answer to be 2772 centimeters square. So this is our curved surface area. Now to find the total surface area, we have to do 3 pi r square, right? So now let us substitute the values. 3 into 22 by 7 into our r is 21 into 21. We'll cut it by 3, and when we do the multiplication, we get our answer to be 4158 centimeter square, and it is centimeter square because our radius is given in centimeter. So this is how we find out the curved surface area and the total surface area of a sphere, of a hemisphere. Now moving on to our example number 9. Here it is said that the hollow sphere in which circus motorcycle performs his stunt has a diameter of 7 meters. Now the circle motorcycle performs a stunt in a circle in a sphere, in a hollow sphere which has diameter of 7 centimeters. Now the area available to the motorcycle for riding, even if it is a sphere, now let us move on to our example number 9. That is our next example. Now in this question we are given that the hollow sphere in which the circus motorcyclist performs his stunts. That is, there's a hollow sphere, and inside it a circus motorcyclist performs his stunt. We can consider this to be a cycle. Let's just consider, even if it doesn't look like one. So there's a circus motorcyclist and he performs his stunt inside this hollow sphere, and it has radius of 7 meters. We have to find the area available for motorcyclists to ride. That is, we have to find the surface area of this sphere, right? Because the area of the sphere is the area on which motorcyclists ride, as it is given over here. So now to find the area, we simply have to do 4 pi r square, which is our surface area of circle. So 4 into 22 by 7 into r is our 7. It is not that r is not 7, but r is given, our diameter is given. So diameter is 7 meter, but we have to find r. So our r would be d by 2. So it is 7 by 2, which is 3.5 centimeter, right? So either we can write 7 by 2 or we can change it to 3.5. So I'll just write it like this, and when we cut it, we get 4 into 22 into 7 upon 2 into 2. Now we can see there are a lot of common. So we see 2 into 11 into 7. Now when you multiply this, you will get 154 meters square. Here it is meter square because our diameter is given in meter. And so our radius will also be in meter. So this is how we find out the answer to this question. And now let us move on to our next example, our example number 10. So in this question, we're given that a hemispherical dome of a building needs to be painted. That is, this dome is need to be painted. If the circumference of the base of the dome is 17.6 meter. Now the circumference, let me draw the sphere over here. Now it is given that this area, the circumference, is given as 17.6 centimeter. We have to find the cost of painting it. Given the cost of painting is 5 rupees per 100 centimeter. Now the painting is to be done only in the outer walls. That is, we have to find the CSA of this hemispherical dome. So we know the CSA of a hemisphere is 2 pi r square. But we do not know r over here. The information that we are given is that the circumference of the base of the dome is 17.6 meter. So we can find out the radius from using this information. Since we know the circumference of a circle is 2 pi r, which is equals to 17.6. So now when we substitute the values, we get 2 into 22 by 7 into r, which is equals to 17.6. And so r will be equal to 17.6 into 7 plus 7 upon 2 into 22. And when you will calculate the radius from here, you will get 2.8, and it is meter, since our circumference is also in meter, right? So it is 2.8 meter. Now we have got our radius, r is equals to 2.8 meter. All we have to do is find out this CSA. I'll just erase this part out so that we can get some space to do the question. Now the CSA is given as 2 pi r square, so let me write 2 into pi is 22 by 7 into r is 2.8 into 2.8. So when we do that, we'll calculate this, we'll get the answer. We can cut it as 0.4 and we'll get the answer to be 49.28 meters square. So this is our curved surface area, but we have to find out the cost of painting it. And the rate given to us is 100 centimeter square will be painted at 5 rupees. So from here, we know that 1 centimeter is equals to 100 centimeter is equals to 1 meter. So 100 centimeter square, that is 100 into 100 centimeters square. We have multiplied 2 times 100 is equals to 1 into 1 meter into 1 meter, so that we get meter square. So here if 100 centimeter square is given, to convert it in meter, we have to do 100 into 100 centimeter square, which will give us 500 rupees, and this will be converted into 1 meter square is equals to 500 rupees, right? So to paint 1 meter, we have to pay rupees 500. Now we have to paint 49.28 meters square. So to find out the total cost, we multiply this CSA value with our painting value. So our total cost will be 49.28 into 500 rupees, which will give us 246,400. So this is the amount of paint, or this is the amount of price that we have to pay to get our dome painted. So now you have learned how to find the curved surface area and the surface area of a sphere or a dome, and we have also analyzed by using activity, and which is equivalent, that we have almost proved and seen how the formulas have come.